From the Millersville University Weather Center, I'm meteorologist Kyle Elliott here with my 2024-2025 winter outlook. In stark contrast to last year, we are going back into a state of La Nina this winter, and I do believe that that's going to play a big impact on temperature and precipitation patterns across the United States this winter season. So without further ado, let me jump right on into my winter outlook PowerPoint, and I'll start by recapping the 2023-2024 winter season. And to be honest, there really wasn't too much to recap across southeastern PA, northern Maryland, and the lower Susquehanna Valley. It was the third consecutive winter with below normal snowfall, with only 18 inches of snow at Millersville University, most of which fell in generally 3 to 6 inch increments in January and February. You can see here that generally all of the lower Susquehanna Valley picked up between 1 and 2 feet of snow last winter season. Compared to average, that was about 50% of our long-term average seasonal snowfall, which ranges from around 20 inches in southern Lancaster County to nearly 40 inches in parts of northern Dauphin and Perry counties. So as a recap of some winter climate influences, first we have the interseasonal or year-to-year influences. These are ocean sea surface temperature anomalies in the Pacific Ocean. First we have the state of ENSO, i.e. La Nina or El Nino in the equatorial Pacific, and then the Pacific Decadal Oscillation, which is essentially the distribution of SST anomalies in the northern and northeastern Pacific Ocean. We also have intraseasonal influences, and these are generally vary on time scales of a few weeks to a couple of months. These are the jet stream blocking and tendencies, such as our North Atlantic Oscillation, Pacific North American Pattern, Arctic Oscillation, Eastern Pacific Oscillation, and Mann-Julian Oscillation. And then finally, we have daily, weekly weather and trends. These are more difficult to predict more than 7 to 10 days in advance. Those are our snow cover, ground moisture, and recent storm tracks. So taking a look at sea surface temperature anomalies across the Pacific Ocean from November 4th, what we see is below normal SSTs in the equatorial Pacific. Those are representative of La Nina. During La Nina winters, there tends to be an active storm track into western Canada and the Pacific Northwest with a lack of big Gulf and East Coast snowstorms. So what happens is you tend to get your strongest gradient in sea surface temperatures here in your north central Pacific. So you have a stronger northern branch of the jet stream and weaker southern branch. So your storm track tends to track more into the Pacific Northwest and then essentially across the central and northern United States. These storm systems are not able to tap into the deep, rich Gulf of Mexico and Atlantic moisture, such as if we had a storm track in the southern branch of the jet stream. Those deeper, stronger southern systems that tend to crash into the coast of California and then barrel through the southern U.S., well, they're more likely to pick up that Gulf of Mexico and Atlantic moisture. But in La Nina, again, those systems tend to track farther north and west across the drier parts of the North American continent, and so they don't tend to become as strong. We also have a strongly negative Pacific Decadal Oscillation, which is currently actually near record low values, and that will lead to persistently chilly weather in Alaska and the western North America, and then milder conditions in the southern and eastern United States. So oftentimes when we see this strongly negative Pacific Decadal Oscillation, we'll see what we call the Gulf of Alaska low. Now, for snow lovers and winter weather weenies, that's really the kiss of death, because when you have that Alaskan vortex in place, you tend to have a dip in the jet stream here across Alaska and also into the Pacific Northwest and Western Canada. And what goes down must come up. So if you have a mean trough in the aggregate over Alaska and Western Canada, you tend to have a bulge northward in the jet stream across the southern and eastern United States. So again, that also promotes those milder and wetter conditions rather than the colder and snowier conditions. So how do I go about forecasting or making a winter forecast? Well, it's pretty simple, to be honest with you. I look at the distribution of temperature and precipitation patterns across the U.S. in past winters with similar conditions to those I expect in the upcoming winter. These are called analog years, and they're a vital part of seasonal forecasting. So for this upcoming winter season, I've picked out 6 analog years: 1988, 89, 1998, 99, 2005, and 6, 2008 and 9, 2016, 17, and 2022, 2023. So you'll notice this chart that I'm showing here is of the multivariate ENSO index, or MEI. It's essentially a measure of how well the atmosphere is responding to the sea surface temperature changes in the equatorial Pacific. Oftentimes you'll see the atmosphere lag these sea surface temperature changes by several or more months. In this case, that's not happening. I think part of that has to do with the fact that last winter the pattern really never adjusted to that brief El Nino that we saw And I think a large part of that had to do with the fact that we had La Nina conditions. In fact, very strong La Nina conditions in the equatorial Pacific for the previous 3 winter seasons. You'll notice already that the MEI index has gone back negative, and it is suggesting that the atmosphere is already behaving like we're in a state of a weak to moderate La Nina. And I think that's what we're going to continue to see throughout much of the upcoming winter. Now, I'm not also looking at the ONI or MEI index, the state of La Nina or El Nino, but I also am trying to find winters that not only have that La Nina in place, but also a strongly negative PDO. Most of these winters are a good match there, the only exception being 2005, 2006, and to some extent 2016, 2017. But again, you can see in most of these 6 analog winters, the PDO was strongly negative. So here's an average of the snowfall in the 6 analog years. You can see that here at Millersville, the average snowfall in those 6 years was a measly 13.9 inches. That's only about half of our long-term 40-year running average, which is around 28 inches. You can see that snowfall totals in those individual winters ranged from a measly 0.9 inches in our least snowy winter on record 2 years ago in 2022, 2023, to 23.6 inches in 2005, 2006. But you see the other 4 winters, our seasonal snowfall was all between 10 and 20 inches. So again, as a betting man, that would be what I would be expecting this upcoming winter season, about 10 to 20 inches of snow across the Lower Susquehanna Valley. So as you see, take a look at the model projections of ENSO from October 2024. What we notice is that most models agree, both the dynamical and the statistical models suggest that we are going to be in this state of a weak La Nina into the upcoming winter season. And there are some that suggest that the La Nina could be stronger than others, but no matter how you slice it, I do have pretty strong confidence that La Nina is going to stick with us through the upcoming winter. So again, how do I do this? Well, I crunch temperature and precipitation anomalies in each individual month of those 6 analog winters, and then I do a composite of all 3 months, December, January, and February, to get a general look at the winter as a whole. So for the December 2024 outlook, you'll notice that the temperature composite of those 6 winter seasons actually suggests that temperatures could be near to slightly below normal across much of the mid-Atlantic states. But at the same time, you'll notice that those 6 analog years generally had less than normal precipitation across the southern and eastern United States. Again, very typical of La Nina. You'll notice in my forecast that I'm actually expecting temperatures to be 1 to 3 degrees above normal. And that's because I'm skewing towards some of those warmer winters, such as 2022, 1998, that also had the more strongly negative PDO in place. I'm expecting near to slightly below normal precipitation, and really this is par for the course over the last few winter seasons. I'm only expecting about 1 to 3 inches of snow here in Lancaster County in December. Again, the average of those 6 analog years was only 2.1 inches, and in the last 3 to 4 winter seasons, we just really haven't seen much of any snow at all in December. As we move forward then into January, you'll really notice that pattern flip, and the core of the cold and winter weather kind of shifts into the western United States with a storm track into the Pacific Northwest and California. You'll also notice that you have another stripe of above normal precipitation stretching from the Tennessee River Valley up into northern New England and the Great Lakes region. So that suggests that we may have a secondary storm track up the Appalachian Mountains into the Great Lakes region in January. So I do expect precipitation to be near normal in the Lower Susquehanna Valley, but wow, it looks like a really mild January compared to normal. Temperatures some 3 to 5 degrees above normal with a monthly snowfall forecast of only 3 to 6 inches here in Lancaster County, 3.8 inches being the average of those 6 analog years. Compared to normal, we usually get about 8 to 9 inches of snow at Millersville in January. So again, going along with that overall theme of winter with below average snowfall in January. February is essentially a carbon copy of January. Really don't need to rehash what I already said. The average snowfall, 40-year running average in February here in Lancaster County, again, is around 9 inches. I'm expecting about half of that this February. So as a whole, you can see that this winter looks like it's going to favor colder and more wintry weather in the Rocky Mountains and the western United States, with milder and wetter weather in the southern states, the southeastern U.S., Carolinas, and the mid-Atlantic states. And again, that's really par for the course in La Nina winters with a strong negative Pacific Decadal Oscillation. As far as the precipitation departures, I do think that precip this winter season will be near to slightly below normal. But again, with all that mild air in place, snowfall is going to likely be well below normal. So as a recap for some of this winter's highlights, I expect La Nina and a strongly negative PDO will be 2 major factors this winter. Something I haven't mentioned yet, but compared to last winter, I do expect the stratospheric polar vortex to also be stronger this winter, so that will tend to favor a more zonal west to east oriented jet stream, and really the core of that cold Arctic air staying locked up in high latitudes for much of the winter season. The storm track, therefore, will more often be to our northwest than to our southeast, with a lack of strong coastal storms and a higher number of weak moisture-starved systems. I do expect several changeover storms where precipitation begins as snow, but then at the height of the storm changes over to sleet, freezing rain, and/or plain rain, with more of those all-snow events being confined to the Ohio Valley, New England region, and Great Lakes. So along with that, I expect a reduced threat of a major nor'easter in the major cities of the I-95 corridor, with long, mild periods, with the risk of a brief but pointed cold snap sometime around the holidays, and then perhaps late in February or early in March. And that really is going to depend on the strength of the stratospheric polar vortex and whether it starts to weaken late in the winter season. Overall, I expect it to be colder and snowier in the northern western U.S. and milder and less snowy in the southern and eastern U.S., with aggregate temperature departures here in the lower Susquehanna Valley about 2 to 4 degrees above normal. And again, to recap that total snowfall forecast from December through February, I'm expecting about 50% of average in Lancaster County, with a lower than average risk of a major 12-inch plus snowstorm. Well, there you have it. That's my 2024-2025 winter outlook. We'll see how it does, so you'll just have to stay tuned over the coming months and see how things play out.